So in this case, we are going to continue with our derivative from the first principles, looking into a condition where we are given a constant, where y is equal to c, and c is representing what? A constant. For an example, we are given here, find the first derivative with respect to x, f prime x, from what? First principles, if our f of x is equal to 3. We do not have x there. It's just a constant that you're given. So what is then going to be the derivative from first principles? As our formula requires that, we are going to need f of x, which we already have, and also f of x plus h. So our f of x is 3. What about f of x plus h? What does this part actually mean? This means here, in place of x, from f of x, let's say f of x is equal to 3x. Let's say this is what we have. And you want to find f of x plus h. You're going to substitute that. In place of x, you substitute x plus what? X plus h. You put x plus h there, where there is what? X, in place of x. So in our case, it's f of x and we need f of x plus h, where we do not have x. It is just like, all right, x to the exponent of 0, if you want to take it that way. So whatever that you're going to have, it was going to be x plus h to the exponent of 0, which is equals to 1. And 3 times 1 is going to give us a 3. So meaning to say, our f of x plus h is not affected, cannot be calculated, is just going to be equal to 3. There is nothing that we are going to substitute in place of what? In place of 4, or in place of x, because we do not have x. So meaning to say, this is what you are going to have as your solution. Our first derivative with respect to x was going to be the limit as h approaches to 0. Then we're going to have f of x plus what? H, which is what? Which is 3. Our f of x plus h is 3 minus, all right? So we're going to subtract. What are we subtracting? F of x, and f of x is equal to what? F of x is also equal to 3. So everything over h, our denominator, it's what? It's h, like this. So guys, this is what you're going to have. There's nothing that you can substitute, so it remains as it is, as a 3. Then, when you are to simplify, this is what you're going to have as h approaches to 0. This is what you're going to have. 3 minus 3, that's what? That's a 0. So you're going to have 0 over h. Remember, 0 over a constant gives us a 0. It is 0 over 2, that's a 0. This is not a constant over 0, which gives us infinite. No. 0 divided by any number is a 0. So meaning to say, this was going to be limit as h approaches to 0 of what? 0. 0 over h, that's a 0. So this is what you're going to have. And what does this part mean? It is the same as that f of x plus h. When we say there's nothing to be substituted, it is the same thing here. We are saying as h approaches to 0, we must substitute 0 in place of h. Do we have h? We do not have h. There is no h in our on this term. It's just a 0. So there's nothing to be substituted. So meaning to say, we are just going to obtain the 0 that we have. So therefore, this is our first derivative with respect to x. It is going to give us what? It is going to give us a 0 for any constant. So this is what you must take note. For any constant, y is equal to 2. It means the derivative of y with respect to x, since we do not have x there, is going to give us a 0. Whether it is a negative 10, the derivative of y with respect to x is going to give us a 0, as long you are dealing with a what? A constant. As long you are dealing with a constant, the answer is going to give you a 0. So you can try anything, guys, where f of x is equal to -3, where f of x is equal to 100, whatever that you want, you are going to obtain 0 at the end. All right, so that is it for this class. As we can see, it was a direct and straightforward application when we are dealing with a constant. There's no, we do not have a lot of things actually to consider. It is a straightforward thing that you can follow up. So do this whenever you are given a constant to differentiate it from the first principles.